Now, for most people, they got this wrong because they just stated the theorem. Opposite angles in a cyclic quadrilateral add to 180. But actually what this is wanting you to do is it wants you to prove the theorem's correct. Now, to prove the theorem's correct, what you need to do is to start by drawing in all these lines to the radiuses, or the radii. Now, A to C isn't necessarily diameter, and B to D isn't necessarily diameter. So the first thing I'm going to need to do is label up each of these points here. What it does, however, mean is that from B to O to C is an isosceles triangle. From C to O to D is another isosceles triangle. A to O to D is another isosceles triangle. And the last one is also an isosceles triangle. Which means to work out the bottom angle of any of these, what we're going to do is 180. We're going to minus away the top angle and then divide it by 2. So that will be that one. These two here will be 180 minus B over 2. And let's change colour for the rest. So this will be 108, so much for changing colour, minus C over 2, and 180 minus D over 2. So these are all these little angles here. Now, having got that, what I can then do is have a look at these two opposite angles. So I'm going to look at A and I'm going to look at C. Can I change colour now? Yay! So these angles here means this angle, which happens to be 180 minus D over 2 plus 180 minus C over 2. And these two angles here, which happen to be 180 minus A over 2 and 180 minus B over 2. Now, in theory, all these two angles added together should give me something. So don't forget as well, because we use these numbers in the circle, we also know from this that A plus B plus C plus D should equal 360 degrees. So moving to blue, I'm going to do 180 minus A over 2 plus 180 minus B over 2, which is these angles here. And I'm going to add to it these angles here, which is 180 minus D over 2. And I'm going to add 180 minus C over 2. So I've got all these four angles added together, and I'm going to see what they all total. So let's separate out the 2. So that's 180 over 2 minus A over 2. And I'm just going to do the rest. There we go. Now, 180 over 2 ends up being 90, so I'm going to change all of those now to 90. And that gives us the following. So altogether I've got 90 plus 90 plus 90 plus 90, which is 360. And I'm minusing away from that, and I'm just going to put a brackets in, a half of each of A. So I'm minusing a half of A plus B plus C plus D. So this bit here, I've taken the half out of each of these and put it in front, taken the minus out of each of those and put it in front. So expanding this, that would give me minus a half A, minus a half B, minus a half C, and minus a half D. And so I already know that A plus B plus C plus D from up here is 360. So I've basically got 360 minus a half of 360, which is 180. So 360 minus 180, and that's 180. So regardless of your value of A, B, C, and D, you're always going to get 180 degrees when you add up these two angles. And the same principle works true for these ones. The only difference is your pairings would be B and C paired here instead of C and D and A and B, and the other side would be D and A. Either way, you're still going to end up with the same number. A hard question.